Hello viewers, the topic is quicksort recursion stack. It has been noted that people frequently struggle to comprehend the recursion stack that the quicksort algorithm produces. In today's video, I will try to explain how the recursion stack is created and maintained during the execution of the quicksort algorithm. The quicksort algorithm and the partition subalgorithm both are displayed here. The objective of quicksort is to sort a given array, and the partition algorithm plays an important role here. It chooses the last element as the pivot and finds its proper location inside the array, which divides the given array into two subarrays, the left subarray and the right subarray. A complete explanation of the partition subalgorithm is given in my video partition subalgorithm for quicksort, and the link is given in the description. Today I will only explain how the stack is created and maintained in quicksort. Let us consider this example. Let us assume that this is the array A, which contains 5 elements 7, 1, 5, 4, 3, which is an unsorted array, and we will apply the quicksort algorithm to this array and will sort the elements. So I have already drawn this recursion tree for the convenience of the users, and we will refer this one, and we will also create the stack, and we will push the calls one by one and we'll see. And let's say the first call is qsort. Instead of quicksort, I have written qsort A15. Why A15? Now let us refer to the algorithm. The whole call stack I have created here to make the video short. So you see the algorithm quicksort APR. P is the starting index, R is the last index. So the first call is qsort A15. P is 1 and your R is 5. So this condition is satisfied 1 less than 5. Immediately partition algorithm is called. So here we see the partition algorithm, it is called, and at the end of the partition algorithm the pivot, which is 3, got its place, which is index 2, and this index is returned, which uh, is 2 here, and the value is assigned to q. Now here you see there will be two calls, that is qsort A1 q minus 1, which is 2 minus 1. So qsort A11, and it is pushed to the stack. This will not be generated right now. So initially qsort A15 was there. Now qsort A11 is pushed onto the stack. That can be seen from here. So qsort A15, it is already in the stack, which is this. Then qsort A11, it is pushed onto the stack. Here you see A15 is there and A11 is pushed onto the stack. So when this is pushed onto the stack, this will be called. This is called and pushed onto the stack. So now P is 1, R is 1, and this condition is false. That means the algorithm is complete for this call, because if the condition is true, then only these 3 lines will be executed. Because the condition is false, it will terminate itself. So q11, it is pushed onto the stack, called and pushed onto the stack, and immediately popped off from the stack. So For q sort a15, this call is completed. Now this recursive call will happen. So now this is q sort a35. So now this will be pushed, called and pushed onto the stack. Now see this, q sort a15, then q sort a35 is pushed onto the stack. So here you see this one is popped off, which I have indicated by uh, placing this cross mark. Now q sort a35, it is pushed onto the stack. It is already there. So a35 pushed onto that. Now 3 less than 5. So partition algorithm will be called because the condition is satisfied. Q sort a35 p less than r. So partition again will be called. Now the pivot is always chosen as the last element. So 5 is chosen, and from here we can see the pivot which we have chosen got its place, and the index is returned, which is 5. Since 7 is the largest element, its position is not changed at the end of the partition algorithm. So 5 is returned, and this 5 will be assigned to q, and there will be two more calls, but this call will not be generated. This one will be generated and called and pushed onto the stack as well. So a15 was there, then a35 was there, and now your a34 is pushed onto the stack. So that also can be seen, from here, a34. Now you can refer to this a15, then a35, and a35 recursively calls this. So a34 also pushed onto the stack. Now this also p and r, p less than r satisfied. Again there will be two more calls, but only one call will be generated. So a34, and here partition a3 less than 4. So partition algorithm will be called. Now this partition algorithm chooses this 3 4, chooses the last element, which is 4, as the pivot element, and got its position as index 3 at the end of the partition algorithm. Now this 3 will be returned and will be assigned to the q variable. So now assigned to q variable. So there will be two more calls, but only one call will be generated. So q sort a32, ap, which is uh, 3, and q minus 1, which is 3 minus 1, 2. So this is called and pushed to the stack. Now see this, called and pushed to the stack a32. Since p less than r, this condition is false, it will be immediately removed. Similarly, next, for a34, this call is generated. Now see this, for a34, this call is generated, pushed, and also popped off. Then this will be generated. Once this is complete, we will consider a34 is complete. So q sort a44, which is key plus 1, that is your 3 plus 1, 4, and r is 4. So this is also pushed. Onto the stack a44. So this also p less than r condition not satisfied. So it is also popped off. So once this is popped off, q sort is considered complete. So this also will be popped off. So again it will come here a35. If you see this a35, this one is completed, but this one is pending. So now this one will be called and pushed onto the stack. So here you see this pushed onto the stack, and because the condition is false, p less than r, this also popped up, and once this is popped up, we consider A35 is also completed. A35, because both the calls are completed for A35. So this will be popped off A35, and for qsort A15, this and this both are completed, so this will be popped up. So the stack will be empty, and you will get 1 3 4 5 7, that is the sorted array. So here I have missed one thing, that how the elements are uh, the pivot is chosen and location is fixed, that I have to explain right now. So please have patience. See this from the very beginning. When the first call is made, partition algorithm is invoked, and the pivot, which is 3, it got its position. So the position is fixed. That means it is not going to be changed. The index 2 for 3 is fixed. That is the objective of partition algorithm. Then it has uh, two more arrays. The right subarray contains 5 4 7. The left subarray contains only one element. So this call is made for that, the left subarray. Since it contains only one element, no partition algorithm will be called, and this is the position of 1 also. So I have kept both of them in a box only to indicate their position is fixed. They are not going to be changed henceforth. So now the right subarray remains, and again partition algorithm is invoked, and the pivot, which is 7, it got its position at the end of the partition algorithm. So 7 position, which is index 5, it is also fixed. It is not going to be changed. But one thing you can see, when 3 was chosen as pivot, here left subarray contains only one element, right subarray contains 3 elements. That's why you can see the call is A11. If only one element is contained, you can see the starting index and the last index is same. But if there are 3 elements, so here 3 4 5, 3 to 5, right subarray. But here you see, when this is called, 7 got its position, only the left subarray is created. Right subarray contains 0 elements. That's why you can see the left is A34, 3 4, only 2 elements, but right contains 0 elements. That's why X65. That means the starting index position is greater than the last index position, which happens if the array which is generated after the partition contains 0 elements. So 7 divides the given array, which is this much. Left subarray contains 2 elements, right subarray contains 0 elements. So we got this call for that. Again, let us come here. Now we are left with only two elements, that is 5 and 4. This was chosen as the pivot, and it got its position, that is index 3. It is also fixed, and it creates only right subarray, left subarray is 0. That's why left subarray, you see the starting position is 3, the last index is 2. So it is greater than the last index position, because the left subarray contains 0 elements. If you consider only this much, 4 5 and 4, so 4 got its position, 5, and then the right subarray contains only one element, that is 5. That's why this is A44. And after this, because all of the elements have got their locations, proper locations in the array, there will be a series of call stacks, a series of calls. They will only be called and pushed onto the stack and popped off. And once the stack is empty, the array is a sorted one. So you can generate the recursion tree this way, then can trace how the call stack is made like this: q sort a15, then this will be pushed, again this will be popped up because of the condition, then this one will be pushed onto the stack, then this one will be pushed onto the stack, then this one will be pushed onto the stack, this is popped up, then this one will be pushed again, then this one is popped up, and this one is also popped up, then again this one is pushed in onto the stack, and this one is popped up, and this one is also popped up. Now q sort is the last one to be there in the stack, and this one is also popped up. Once this one and this one is popped up the array, and by that time you will see the array will have uh, positioned all the elements in their proper locations, and the array is a sorted one. Thank you viewers for watching this. Please subscribe my channel, hit like button and press the bell icon to get more such videos.